All right, this is Coach Williams. I am going to do the Chapter 7 test review with you guys. That way we've got, I know some students that are out today, and so we want to make sure that you guys have every opportunity to get the review in. Our test is tomorrow, so we will send out this link to all you guys. Make sure you get this. The first few problems, actually first several problems, this is obviously Chapter 7, so the first few problems that we're going to see are going to be Chapter 7. So all the way through the first page, you're going to see all Chapter 7 problems. Whenever we get to ones that are not Chapter 7, I'll be sure to mention those chapters as we move along. Okay, so on the first part, it asks you to define the sum. And so when we're finding the sum here, the sum just means addition. So we're going to we can mark that up if you want to. We're going to add these two together. When we add, then you don't have to worry about parentheses on the outsides. You can just take the terms for what they are as far as their signs are concerned, and then you can combine like terms. Now, with that being said, I know I can add x squareds to x squareds, so a 9x squared plus a 3x squared is going to give me 12x squared. All right, the next terms that I can put together are going to be x to the first power, or just plain x terms. And so I've got two of those. I have a 4x and I have a negative 3x, which is going to simply make a positive x, or 1x. If you wanted to put the 1 in there, that'd be fine. And then lastly, I have a constant term of negative 7. There's nothing else to combine with that, so I'll just have negative 7. And that is my answer, all in multicolors there for you. All right, so that is finding the sum. This is a trinomial, has 3 terms. That's a binomial that has 2 terms. Again, using addition, you don't have to worry about sign changes. Okay, the difference is going to be the next one. And you'll notice here, difference, we're going to have to do a minus sign. And when you have a minus sign in front of the parentheses, that means you're going to have to change the sign of everything in this side. The one after the minus sign, everything in that parentheses is going to have to change signs. So rewriting this, I'm going to have a negative r. Minus 10, that doesn't change. But the negative here is going to change to positive. This is going to change to a negative. And this is going to change to a negative as well. All right, so a lot of negatives there to deal with. But we're still going to rewrite this, and we're going to make sure our answer is in standard form. And so if I start with the highest degree polynomial, that's going to be the 4r cubed. So 4r cubed would be my first term. Go ahead and mark through that because we're done with it. The next one will be x squared. Take the sign with it. So I'm going to have a minus x squared. The next one's going to be one that will combine. So let's mark what it combines with. We have 2 r terms. One is negative r, one's negative 7. That'll make a negative 8r. And then again, we're going to have a constant term here that's just all by itself. Nobody to join with, so we're going to have a negative 10. And again, that is my answer in standard form. 4r cubed minus r squared minus 8r minus 10. Okay, find the product. Product simply means multiplication. Okay, so you can mark that out and put a little multiplication sign if you wanted to. There are several ways we could approach this problem. You could use the FOIL method, and that just means we're going to use distribution. We would take this 5x, multiply it times the x, multiply it times the negative 2, and then we would, once we get those 2 terms, we would then add to that the 6 times x and the 6 times the negative 2. All right, that would be one approach you could use. One I'm going to show you or demonstrate to you is the one most everyone is finding easy to use, and that's the box method. Okay, so if I'm using the box method, I'm going to draw a little box here, come across, and then now I'm going to put both the terms from the first binomial. I'm just going to put those right here on the left, 5x and 6, and then the 2 terms from the right binomial, which will be x and negative 2. And then from here, what we're going to do is we're going to just multiply the 2 terms together where these would join. So 5x times x is going to give me a 5x squared. Okay, 5x times negative 2 is going to be a negative 10x. And then 6 times x will give me 6x. 6 times negative 2 will give me a negative 12. And then something we always like to make note of is that our middle terms, in most cases here, are going to combine. So those are our like terms. We can combine like terms. So the final answer here will be 5x squared. 6x and negative 10x make a negative 4x, and then we have minus 12. And that is in standard form as well. Okay, simplify. And when it says simplify here, we're not trying to solve anything, so we don't have an equal sign. We're not trying to get an A equals answer here, we'll say. But this is something we should begin to start recognizing as we're moving through these problems. This should be something we recognize from one of our sections in Chapter 7. This is a difference of squares. Okay, difference of squares. That means we have a scenario where we have an A plus B times an A minus B. The A is an 8, the B is the 3A. And if that's the case, our, multiplied out, or, if we fold this or we did the box method, what we come up with is going to be A squared minus B squared. And that's just a simple little form we can use because the middle terms are going to cross or cancel out whenever we do this by, long multiplication, you could call it. So that if that's the case, then I'm going to note here, my A is the 8. And I have 8, and I'm supposed to end up with this right here, 8 squared. My B is 3A, so I should end up with minus 3A squared. Okay? And if I go ahead and simplify those out, then this will be 64. And 3A squared is going to end up being 9A squared. And that is my final answer. That's a difference of squares. Okay, I am moving through this rather quickly. So obviously, we're just for sake of time, we want to get all this in. You can take the video, slow it down if you want to. Obviously, you can stop it and pause it, rewind it, and watch over any steps that you may feel uncomfortable with and want to get a little more review on. So that's up to you as we go through this. But I will move through this pretty quickly. It is a review, so we should have a pretty good grasp of all this. All right, find the quotient, and quotient means we're going to divide again. So this is 6x minus 18 divided by 2x minus 6. This term is not 1, and so I'm going to use long division here. If that were a 1, I could use synthetic division, be a perfect candidate for synthetic division. But since it's not, we'll resort to 6x minus 18, long division here, divided by 2x minus 6. Now, again, we always like to note what are we looking for here to help us find the terms that we would, multiply times 2x minus 6 to get to this. And we're really looking at these first terms here. So what is 6x divided by 2x? That's one way to look at it or say it, and that's going to be a 3. One thing we have to remember as well is that this is a binomial. So if I'm multiplying 3 times 2x, then I have to multiply 3 times the negative 6 as well. So this 3 times 2x is going to give me my 6x that I was looking for. And then 3 times the negative 6 will give me a negative 18. And that works out very nicely because when we subtract all this, you're going to end up with 0. So there's basically no remainder. So my answer here is 3. 2x minus 6 times 3 would give me 6x minus 18. Okay, let's look down at the last problem on the page. Again, we're finding the quotient. But here, when we find the quotient, this is a perfect candidate for synthetic division because the coefficient in front of x is actually 1. And so because it's a 1, that works out real nicely for us to use synthetic division. So what do? We take this term in the binomial and we use the opposite sign. So we're going to have a positive 3 sitting here. Okay, make our little bracket here to help us out. And then we're going to look at the terms. The coefficient of each term here, you're going to have a 1, a 6, and a negative 27. Those will be the 3 values you'll place here. 1, 6, negative 27. And then the first step to this crazy magical process of synthetic division is that you bring down the 1. When you bring down the 1, and that's very, very critical. We have a lot of students who want to go ahead and multiply 3 times 1 and put it as the first term. Don't do that. It's a common mistake. Just bring the 1 down. That is the first term here. So we're going to have 1 brought down. Then you're going to multiply 3 times 1, and that's going to give you a 3. Whenever you add 6 and 3 together, you get 9. Multiply 3 times 9. That's going to give you 27. Add these together. You're going to end up with a 0. Remember that this last term is your remainder. This is your constant moving from right to left. This is your x, the first term. If we had more terms, you'd go x squared, x cubed, and so on. Okay, so you'd have all of those sitting out there if we were doing this and we had more terms. Now, we don't have any more terms. There is no remainder, so this works out really beautifully. We're just going to have 1x to the first power plus a 9, or just simply x plus 9. And that is the answer for number 6. All right, let's flip the page. On to number 7. Okay, number 7 wants us to factor out 6x squared minus 21. Okay, so 6x squared minus 21, we're just factoring. And so if we're just factoring, we are doing, when we have 2 binomials, we're not trying to solve for x. We just have 2 terms, which is a binomial. We're going to factor out one thing if we can, right? So we're going to look for one thing that will come out of both of these. And the greatest common factor that we can find when we look at both of these is a 3. So we're going to pull a 3 out front. When we divide this by 3, we get 2x squared. And then we divide negative 21 by 3, we get a negative 7. Okay, that's pretty much as far as we can go with that. So this is our factored form of 6x squared minus 21. Again, this is still chapter 7, so we're not moving away from chapter 7 until we get down past number 12 down here. We'll see that in just a second. Okay, now we're going to solve. Now this is a little misprint. We should have had an equal sign and a 0. Anytime it asks you to solve, there should be an equal sign involved in the expression. Now, what we start off with here, because there are 3 terms, and this is kind of the little hint that I give my students, 3 terms, I'm going to use the x method. Okay, the top part's a times c, so we got 1 times negative 27 is going to give me a negative 27 on the top. The bottom is always b, and we're looking for 2 factors of 27. Again, one's going to be positive and negative, so what we're looking for is the difference of the 2 factors to be 6. And that works out pretty easily. We know that there's 3 and 9, and I always like to circle the larger factor with the bottom because they will have the same sign. So which one has the negative sign? And it's going to be your 3. And so in this case now, I'm going to write x minus 3. Now, typically we would say over a, but a is a 1, so we don't have to put 1 under the 3. We can leave it like it is because 3 over 1 is just simply 3. That's multiplied times x plus 9 over 1, but again, we don't have to put the 1 there. We know it would just become a 9 anyway. They're still wanting us to solve this, so we set it equal to 0. And then, to solve for the zeros of this function, we're going to set each factor equal to 0. And as we explained in class, if a product of 2, terms is a 0, well, one of them or both of them have to equal a 0. And so we just set x minus 3 equal to 0. That could have been the one that was a 0. X plus 9 equal to 0. And then we do our magic with algebra. So we're going to add 3 to both sides. X is going to equal a 3. Or we're going to minus 9 from both sides, and X is going to equal a negative 9. So those are my two possible answers, or zeros of the function, or solutions, or x-intercepts. I want to make sure you get all those vocabulary terms in there for you. Okay, the other one is roots. So roots, zeros, solutions, or x-intercepts. Okay, factor 3x squared plus 11x plus 6. Oh, and they had to go off and add one of these problems in here for us just to make us sweat a little bit. And that is that we have something other than a 1 in front of the first term. So my a value is 3. I like to write it down just so I don't forget later to make sure and put that factor over a whenever I'm writing out my products. Okay, so we're going to use the x method again. I have 3 terms. I'm going to use the x method. I'm going to start by putting a times c at the top, which is going to be 18. And then I'm going to put my b term on the bottom. And this works out pretty nicely as far as finding factors. The factors that are multiply to be 18, that add to be 11, are going to be 2 and 9. Everything's positive, so we don't have to worry about any kind of signs or sign changes here. Now, the next part is where we have to remember we're going to have x plus 2, but that 2 is going to go over this a. So we're going to have 2 over 3. And that's going to be the first one. The second one's going to be x plus 9 over, and again we put that over a. So this is factor 1 over a, factor 2 over a, and then I have to do a little simplification before I can close this problem out. 2 over 3 doesn't simplify any further, and so we use our little trick here. We're going to take and move that 3 out in front of the x. All right, now it's common to see this on some of our practices and some of our quizzes that you're moving that 3 all the way to the front of the parentheses, but that's not where it goes. It goes right in front of the x. So this one would end up being 3x plus 2, and that takes care of that one. The next one actually works out a little bit nicer for us. 9 divided by 3 is just 3. So I don't have to move anything. I can just rewrite this as x plus 3. Now I am simplified down to the 2 factors that multiply to be 3x squared plus 11x plus 6. Okay, let's move on to number 10. Here they want us to solve. And when we're solving, we have to find out what values of x would, complete or make this expression true. And again, hopefully, we're recognizing some of the things that we're seeing to help us get started on the correct way to solve this. You look here, you should see that this is a perfect square. That is also a perfect square. And so I could say this is actually 5 squared minus, and if I took the square root of 4, that's 2, and square root of x squared, that's just x. So I have 5 squared minus 2x equals 0. Again, we're just working backwards now, but this is a difference of squares. Okay? That's a difference of squares. Now, going backwards, this is a squared minus b squared, so I should end up with a plus b times a minus b. Okay, remember that's the form that we use with difference of squares. So that being the case, I should end up with, I'm going to move it over here, I should end up with 5 plus 2x times 5 minus 2x as the factored form of this difference of squares. This still is equaling 0, and they want us to solve this. Now, a little shortcut that I've used with my students in class is the fact that I know when I set both of these equal to 0, I'm going to end up with the same answer. I'm just going to end up with a positive version and a minus version. Okay, so I don't want you to get away from realizing you have to set this one equal to 0 Set that one equal to 0 and solve. But there is a little bit of a shortcut. I know when I solve this one, it's going to be an answer that's going to be the same as this one, but just a different sign, just because we have this little sign change in the middle. All right, so I'm going to solve for one of them. I'm going to set 5 plus 2x equal to 0. All right, and I'm going to wait on this one for just a minute because I want you to see something here. If I'm going to solve this, I'm going to subtract 5 from both sides. That'll go away. I'm going to have 2x equals a negative 5. Running out of space here, I'll kind of squeeze it in, but I'm going to divide this by 2, and then I'm going to pull this out over here. The 2's will become a 1, so it just leaves me with x, and my answer is a negative 5 over 2. But remember, I said this answer would be the same. If this one's negative, what's this going to be? It's just going to be a positive, version of the same answer. So I'm going to put plus or minus 5 over 2, because I'm going to have a plus 5 over 2 as one of my answers, minus 5 over 2 for the other answer. So you may see it written like that in some cases, or you may see it separated out, x equals 5 over 2, or x equals negative 5 over 2. But that is my solutions for this difference of squares expression. All right, on to number 11. And number 11 is also one that we use a little hint or tip in beginning our solution process, in this case just factoring. But it has 4 terms. And anytime we see 4 terms, we know that we want to look at the option of grouping. So here I am going to do some grouping, and I'm going to group like this right here. Now, when we're grouping, we're looking for a greatest common factor in this group, which in this case is going to be x squared. When I take an x squared or divide both of these by x squared, so I factor that out, I'm left with x, and then take that divided by x squared, and that's going to be plus 1. Now on the second one, I'm looking for the greatest common factor, and it's a 2. Positive 2. If you'll notice, when I divide this by 2, I get an x. Divide 2 by 2, I get 1. And the colors make it real easy to see, but what's the common factor in both of these terms here? And it's the x plus 1. So, if I factor out an x plus 1, I'm going to have an x plus 1. I'm going to take that out of both of these. Here, what is left is going to be an x squared plus 2. And that is about as far as we can go in factoring out that expression. X plus 1 times x squared plus 2. Okay, number 12. This one is a doozy as well. They've increased our numbers and our coefficients on all these terms. And we also notice that this has a d cubed in front, which we're not used to seeing when we're trying to factor out a 3-term scenario. So we may have to do something a little bit extra to get it down to something we can factor that we're used to seeing in a 3-term scenario, or a trinomial, meaning three terms there, okay? So let's see, what can we do? I know that I see that there's a d in every one of these, so it's possible I could get rid of a d, and that would get me to a quadratic or an x squared or a d squared scenario, which I know how to handle. So I know I can factor out a d. I also notice that all these are multiples of 3, right? Isn't this 3 times 5, 3 times 7, 3 times 2? So I can factor out a 3 as well. So, open parentheses here, what's left? If I divide 15d cubed by 3d, I get 5d squared. That one is taken care of. If I divide 21d squared, I'm going to get a negative 7d. Divide this by 3d, I get negative 7d. If I divide 6d by 3d, I'm going to end up with a positive 2. Now we're talking, because this is the type of trinomial I'm used to factoring, and I can do that with the x method. Okay, so I still have this 3d out front, but now this is a little more recognizable and easier to work with. So I'm going to go over here. I'm going to create my little x. I'm also going to note that 5 is my A. Okay, that helps me remember whenever I get my factors, I'm going to put my factor over A and make sure that I create the products correctly. They're those terms, those binomial terms. I'm going to get those correct by putting my factors over A here in just a minute. Now, the top is 5 times 2, or A times C, which is going to be 10. Okay, so 10 is the top. The bottom is the negative 7, and then I'm looking for two factors that are going to multiply to be 10, but add to be a negative 7. Now, if this is positive and that's negative, then these two terms have to be negatives in order two negatives to make a positive, and two negatives add to be a negative. So that's also going to be a pretty simple one, not a whole lot of factors of 10 to work with. So 2 and 5 should be my two factors. They're both going to be negative because negative times negative will be positive, and negative plus negative will remain negative when we get 7. Okay. Again, remembering that I have this 5 for the A term, I'm going to write this out now. I'm going to have D minus 2 over, and the A term is a 5. Okay? That's going to be the first part of this X, factoring over here that we're doing. The next part's going to be D minus 5 over, again, the A value coefficient there, which is going to be, not A, but 5. Okay? And we can't forget that we got to bring that 3D down. That's still part of our factors there. Okay? Now this works out pretty easily on the last one because 5 over 5 is just 1. But we are going to have to use our little trick to get rid of the denominator, pulling the 5 out in front of the D. And so our final answer will be 3D times 5D minus 2 times D minus 1. Okay, that should be factored form of 15D cubed minus 21D squared plus 6D. That should be our final answer there. Okay, number 13. This one goes back to chapter 3. This one goes back to chapter 3. And this is actually pretty simple. We're evaluating basically this expression where x is a negative 2, which f of x equals this expression. Well, instead of x, they just replaced x with a negative 2. So we'll replace x with a negative 2. And if we do that, we should end up with f at negative 2, evaluated at a negative 2, is going to give me 12 minus 2 times negative 2 minus 5. Okay, well, 2 times, or negative 2 times negative 2 is going to be 12 plus 4 minus 5. And so my final answer will be 11. 12 plus 4 minus 5 will be 11. And that's a pretty easy one. All right, let's go ahead and flip the page. We're going to look at number 14. What is the slope of the line that passes through the following points? And we've got a long list of points here. How many points does it take for us to find the slope? It really only takes 2. And so because it only takes 2 points, I'm just going to take the first 2 points, and I don't even need the rest. Does it have to be the first 2 points? No, it doesn't. Well, Coach, will it work if I use 6, 5, and 9, 6? Absolutely. It will also work if you wanted to take a piece of graph paper and graph all these points out and do the slope manually by rise over run. But the easiest way here probably is just to take this and use our 2-point slope form, which is m, the slope, is equal to y2 minus y1 over x2 minus x1. Okay, now let's just plug in our values. Our y values are the 3 and the 4. That's our y values. So I'm going to have m equals 4 minus 3 on the top. Our x values, the x values are going to be the 0 and the 3. So I'm going to have 3 minus 0. Again, just make sure you don't have to start with this point. You can start with that one. Just make sure that if you start with this point for x, you start it with y, or vice versa. If you start this one with y, then you start the x values with this one as well. One of them has to be the one that stays in the front, and so in this case I chose the second point there. All right, this works out easily. This is 4 minus 3, which is 1, and 3 minus 0, which is 3, and our slope is simply 1/3. Okay. Number 15, what is the domain and range of the following graph? And this one goes back in time a little bit for us. But when we're doing this one here, this one's pretty simple. We just have to worry about the values of x and the values of y. This, again, is still Chapter 3. This here, 14, was also Chapter 3. But domain is our x values, and range is the y values. Okay, and we'll kind of mark this on the graph as well. So this is my y values. This is the range. Okay, and then the x values is all the domain values right here. Those are the domain values, or the x values. Okay, noticing this point here, I'm going to work with the 1, and I'm going to work with 4 when I'm talking about the x values or the domain values. When I'm talking about the range values, I'm going to be using 1 and 7, which are the y values of these 2 points. So, when I'm talking about the domain, I know that x is going to be between 2 values or 2 points that they've given us. In this case, it's a 1 and a 4. I'm not going to write in the inequalities just yet because I want to show you the range values, and that's going to be y. And y is going to be between 1 and 7. Okay, so it's all of these values here. Okay, where the domain values were here. Y goes between 1 and 7. And then we have to go back in our memory banks and remember what these open and closed dots mean. The open dots mean I cannot be equal to that value. So if that's the case, I cannot be equal to a 1 for x. I have to be greater than that. I'm on the larger side of x, right? I mean, of the 1 for x. I'm also on the bigger or the greater side of 1 for the y values. So I also cannot be equal to, but I can be greater than the 1. In both cases here for domain and range, I can be equal to the 4, and I can be equal to the 7. So I can be less than or equal to 4, less than or equal to 7. And that should take care of my domain and range of this function. I can be all the values of x between 1 and including up to 4. I can be all the range values from above 1 or greater than 1 all the way up to and including 7. All right, number 16. Number 16, this is going to be Chapter 4. Just for reference, we'll go ahead and put it down here. Number 17 is Chapter 3. Chapter 4, write the equation of a line that passes through the point 2, -3, and slope of -6. And the biggest thing that I teach my students is to take what they give you and just plug it into what you know. Right now, they give us a point, they give us a slope, so let's use the point-slope form, which is y minus y1 equals the slope, or m, times x minus x1. Okay, that's point-slope form. They gave us a point, they gave us a slope, we'll drop it in there. Now, we want to end up with y equals mx plus b, or the slope-intercept form. So that's where we're headed, but we got it in this form, so let's just put it in there and convert it to what we want. Okay, that being the case, we're going to take y minus a -3 is my y value. All right, and then that's going to equal the slope, which is the m is the slope, right? So that's going to equal -6 times x minus 2. Okay, we need to do a little distribution on the right side, and we need to do a little sign change on the left side because minus a negative is positive. So y plus 3 is going to equal -6x when I multiply that times -6 times x. -6 times -2 gives me a positive 12. Now, to get y by itself, I need a minus a 3 and minus a 3. That will go away, and y is going to equal negative 6x. This will become 9 plus 9. And that is the equation of the line that passes through point 2, negative 3, and has a slope of negative 6. All right, number 17, what's the equation of the linear function graphed below? So let's move this up just a little bit so we can kind of talk about it. This one, again, is very simple if you just remember a couple of key points. What is B and what is M? Because if I can find those two, then that's all I need to plug into mx plus b, right? So b is the y-intercept. That is where it crosses the y-axis. And right there, I might have to zoom in a little bit to see it, but that is a negative 3. And then our slope, again, might have to zoom in a little bit, but it's just up 1 over 1, up 1 over 1, all the way through. You could also go up 2 over 2 if you wanted to. Up 2 over 2. Well, any number over itself is just 1, so that's our slope. So plugging this all in, y is going to equal 1x, or simply x, minus 3. That is the equation of the linear function that is graphed right here. All right, let's look at the last two problems of our review, and we will be done here. Number 18 is going to be a word problem involving money. We need to find out how much Mary is making here. It says here, the amount of money Mary makes varies directly with the number of hours she works. After working 9 hours, she makes $114.75. Well, the direct variation, we should remember all that stuff from, I guess, what is this? I guess this is chapter 3. Again, chapter 3 is popular today. And then we have chapter 5 on this, just in case I forget to write that down. This is from chapter 3. And so we know that if it varies directly, then we're going to have 9 times the amount of money that she's supposed to make. It's 9 hours times however much she makes is going to equal the value of $114.75. Okay? And this is actually a very simple problem. You can attack this very different ways. You could actually set this up as a proportion if you wanted to, which is pretty much what a direct variation is. All right, so if I want to find out the amount per hour, I need to divide by 9. That will become a 1, divide by 9 here. And we find out that x is going to equal, or the hourly rate is going to equal $12.75. Okay. Now they want to know how much she makes after working for 5 hours. Well, that's pretty easy. I'm going to take $12.75, and I'm just going to multiply it times 5. So 5 hours times that is going to give me $63.75, and that is dollars. So we put the dollar sign there. So $63.75 would be what she makes after 5 hours. The last problem here is a systems of equations, which is chapter 5. And on systems of equations, one of the things that we look for is, can we do elimination? This is a perfect problem for doing elimination. One of the other things we like to do is, if we're eliminating, we like to make one of them negative. That way we can just simply add all the terms together. And in this case, we need to multiply by -1 on top to change the sign of everything on the top. So if we do that, that's going to make this a negative, that a positive, and that a positive. Okay, so all I did was just multiply by this -1 to get there. Now I can take these terms right here, and I can just add them together. And when I add them together, -3x and 3x will be a 0. 6 and 4y, 6y, 4y will be 10y. It's a positive. And then here's going to be a positive 50. All right, and then if I'm going to find y, I divide by 10. Divide by 10, y is going to equal 5. Now we're not done. We got to take this 5, plug it into one of these two equations up here to find x. So we're going to have 3x plus 4 times, instead of y, I'm going to use a 5, and that's going to equal 14. Now, 4 times 5 is 20, so 3x plus 20 is going to equal 14. And then to solve for x, I need to subtract 20 from both sides. Subtract 20 from both sides. That will go away. Bring your 3x down, still on the left side. And then 14 minus 20 is going to give me a negative 6. Here, I'm going to divide by 3 on both sides. That's going to give me x equal to a negative 2. So now I have the y value, I have the x value. If I wanted to get the ordered pair, I could say it's going to be at negative 2 and 5, where these two functions or linear equations, where the two lines, the graphs would cross, would be a solution of negative 2 and 5. And that is the answer to number 19. All right, I hope this has helped you guys out, and be sure to study for the test, and you'll be in good shape. If you go over this review several times and have it down, you're going to be in great shape for the test. All right, if you have any questions, you can email myself or Ms. Homer with our school email addresses already, or you can shoot back a remind message if you need to ask any questions about anything that you've seen today. All right, y'all have a great day.